here we're going to look at a couple examples of finding the domains of combining functions. Okay. So first of all, the easiest thing to find the domain of functions that you combine together is to kind of take a walk back to your elementary days, the days of the number line, where you would have to draw out your number line to be able to compare numbers. Well, we're going to use that same elementary concept to apply it to domains. So here we want to find f plus g and its domain, and then we want to find f divided by g and its domain, or basically the domain of. So I kind of have the problem set up. We have our two functions. F is going to be x cubed plus 4, and g is going to be the square root of x minus 1. And so what I did is, you kind of want to list out or know all the pieces of information that you're looking for. So we're looking for the domain of f and the domain of g. We want to be able to find the domain of my combined functions when I add them together and when I divide them. So first and foremost, when we're adding them together, we need to go ahead and just simply do that. So to add them together says that f plus g is going to be my x cubed plus 4, and then we're going to add in the square root of x minus 1. And then when we're looking at the division, we have f divided by g. So here in this case, you would have f divided by g is going to be my x cubed plus 4 is in the numerator, whereas the square root of x minus 1 is in the denominator. Okay, so you have to know the overall design first. Now, in order to find the domains, we have to start with the individual pieces. So here we're going to start specifically with just f of x. So here we're looking at x cubed plus 4. Okay. So with that, we know because this is a cube, or a big main parent, meaning it's not a radical, it's not a rational, my domain here is going to be all real numbers. Now where the number line comes into play is going to be right here, if I kind of reveal it underneath my little sticky notes. What you can see here is that I have the big overarching number line right here, and then because I made my f of x blue, I shaded it in blue. So all real numbers means everything. Okay, so this is the negative infinity side, this is the positive infinity, and notice there are no gaps or issues or problems. Okay. Now when we look at g, my g of x is going to be the square root of x minus 1. Now the rule for radicals that you have to remember is that the number underneath the radical must be greater than or equal to 0. That's the rule, because you cannot have a negative under your radical. So in this case, to find your domain would say that we have to have that x minus 1 must be greater than or equal to 0, and we need to solve for x. So in this case, we have that x is greater than or equal to 1. So its domain interval is going to start at 1. Because I have the equals, I'm going to use a bracket. And then we're going to travel all the way up to positive infinity. Okay, so if I remove my next, you can see we've done just that. Again, you would have the negative and you would have the positive. I did my g of x in pink, so you can see here the domain starts where 1 is included and it goes on forever. Okay. Now to find the domains of your combinations, what we are looking for is you are looking for the overlap. Okay. So here, the biggest thing that you have to keep in mind is that the domain of a combined function is the overlap of the individual functions. which is why making these two number lines is so important, because all you have to do is you just simply have to look for the overlap. So here we're looking for f plus g. The only rule that gets used or implied is going to be your radical rule. So we're combining my f plus g together. And so when you would do that according to its number line, it's going to mirror g, okay? Because we're going to overlap these two together and come up with this third one, which means that the domain here is going to go from 1 to positive infinity, okay, because it's just simply the overlap. Now the biggest problem with the last one, or the division, is that we also have to take the fraction rules into account. So in this case we have to note that my g of x is now in the denominator. So if I find the domain for my g of x, I have to now take into account that my radical rule applies, but so does my rational rule, which says it cannot equal 0 anymore, it just simply has to be greater than 0. So in this case, x is greater than 1, which is going to slightly change my overlap. And so what you should notice here about this one is that now at 1 I have this open circle, which means my overall domain for f divided by g is going to come out to being parenthesis 1 to positive infinity, okay, meaning the 1 is no longer included. So that is essentially the easiest way to figure out the domain of your combined function, okay? So just to help make sure that it's clear, let's take a look at one more problem here. And so in this case, again, we want to find the domain, but this time we're going to use f minus g, and we're going to use g divided by f. Okay, so just like before, the first thing you want to do is you want to go in and you want to actually list the formulas. So here we're going to do f minus g. So f minus g is going to be x squared minus 1 minus the cubed root of x. And then down here we're going to do g divided by f. So in this case, when we have g over f, this is going to be the cubed root of x divided by x squared minus 1. Okay, so we kind of have our functions just like before. Now to start working the domains, we have to start back at the beginning. So first we're going to start with the domain of f. So here we're looking at just x squared minus 1. Because I'm not, again, a radical or a rational, my domain here is going to be negative infinity to positive infinity. And just like before, I would draw my number line. So I went ahead and did that already. And so here, all real numbers is going to stretch across the entire number line. We have the negative infinity on the left and positive infinity on the right. We're going to do the same thing for g. For g here, we're looking at the cubed root of x. And so just like before, my domain here is going to be negative infinity to positive infinity. Now, some may say, hold up, wait a second, you have a radical there. But this is a cubed root. It is not a square root. A cubed root can use negative numbers. Okay, that is a big difference between cube roots and square roots, and so therefore, because the cubed root can apply negative numbers into its radical form, we can have all real numbers as its result. So in this case, again, just like before, you can see that we have my number line drawn, which is all real numbers. So now that you have your two base number lines, we can start doing the combination. So f minus g does not have any rationals or square root radicals. Because of that, again here my domain is going to be the overlap. So if we overlap my all real numbers both times, you can see that we still get all real numbers as a result. So here this is negative infinity to positive infinity. Okay. Now the only one that's going to be slightly different is going to be my denominator, because, or my, divisor. And the reason for that is because now I have a rational. And in this case, what's important to notice is that now my f of x is in the denominator, which means I need to look at the domain for my f, which is now going to say that I have x squared minus 1 can't be 0. So in this case, I get that x squared cannot be 1, so x cannot be positive or negative 1, which means its domain is going to go from negative infinity to negative 1, union negative 1 to 1, union 1 to positive infinity. Okay. Now with this, I now have to take this idea and overlap it. But when I'm overlapping it, notice everything else here, my two originals, were all real numbers. So when I overlap an all real number line onto a line that has a domain, well, then the domain is going to carry through. And so what you're going to see here in this one is that at negative 1 and 1, I have holes, which means my domain for g divided by f is going to be negative infinity to negative 1, union negative 1 to 1, union 1 to positive infinity. Okay? So again, it just purely comes down to the overlap between your functions. And so that's why drawing these number lines here is going to be very, very helpful for finding the domains of your functions. So there you have it. Everything you need to know to get started in working with finding the domains of a combination of functions. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I'll see you next time.